All right, so here are two additional examples. First one is going to use the same scenario with Emily, the free throw shooter. I want to know what's the probability that Emily makes at most 4 shots. And then in example number 3, what's the probability that Emily makes between 6 and 9 shots inclusive? So let's deal with example number 2 first. First of all, in terms of just a probability statement, I am looking for generating the probability of the random variable x being at most 4 shots, so taking on values less than or equal to 4. Well, that would mean I could do the calculation and find what's the probability that x is equal to 0, no successes. What's the probability that x is equal to 1, the probability that x is equal to 2, the probability that x is equal to 3, and gosh darn it, I ran out of room, plus the probability that x is equal to 4. I could add up all these individual probabilities and get this answer. Now, what that would require me doing is taking each of these, generating the binomial coefficient for each of them, generating the success-failure statement for each of them, and then taking those 5 values and adding them up. Quite a bit of work for finding out just a single value for this outcome. Remember with binom PDF, I told you that that is for a particular value of x equaling k. Due to the fact that this is an inequality, this is x less than or equal to 4, I can actually apply the cumulative function for binomials. So if I want to find the probability of x less than or equal to 4, I can do binom CDF, the cumulative density function of 10 observations, 0.48 probability of success, and in this case you put your upper limit for the number of successes. So since this is an inclusive 4, I'm going to go up to and include 4. If this said strictly makes no more than 4 shots, there's the phone again. They just keep calling. Hold on. Okay, sorry about that. So binom CDF is right underneath binom PDF, so it's option B in second bars. And again, putting in 10.48 and 4 will generate the cumulative values for p of x equaling 0 all the way up to and including p of x equaling 4. So for this, you should get 0.4270. Now, if you wanted to, you could actually do the binomial PDF of x equaling 0, binom PDF x equaling 1, 2, 3, and 4 individually, add all of those up, and it should equal the exact same value as the binom CDF up to and including 4. You're going to have to be careful about that up to and including versus just up to but not including. So if this problem had read, like I said before, makes no more than 3 shots, or makes less than 4 shots, I guess that would be the better way of looking at it, less than 4 shots, the k value here would only be 3, because you don't get the 4th success. So you have to be careful about that. So even though it may have a 4 in the problem, you may be using a 3. In the next example, what's the probability that Emily makes between 6 and 9 shots inclusive? So again, the probability that she makes between 6 and 9 shots would be x greater than or equal to 6, less than or equal to 9. So if you remember back to when we did our units where we had to use that table in the book for normal CDF, remember that the book only did things cumulatively from left to right. Normal CDF allowed us to put in lower bounds and upper bounds. For some unknown reason to me, the binom functions do not allow you to set lower bounds and upper bounds. So once again, we're going to have to kind of fake our way through this problem with doing more than one thing to get the answer. Still better than doing it by hand, though. And by doing it by hand, I mean that whole binomial coefficient piece. I should say that I know I skipped quickly to the calculator work on this. You do need to know that formula and know how to use it. So please don't overlook the problems or just fake your way through them by using your calculator. Oftentimes on the AP exam, they will give you stuff written in that binomial form. So you have to understand what exactly it means, or they may ask you to do something with the n or the k value in the binomial coefficient. So please don't overlook those. It's just for us getting through these examples, assuming that you can do the simple computations of the factorials, should be enough at this point. So if I consider what I'm looking at here, I'm really looking at p of x equaling 6 plus p of x equaling 7 plus p of x equaling 8 plus p of x, geez, it happened again, plus p of x equaling 9. I need a larger screen. So if the cumulative density function for binomials is only going to work from left to right, meaning that it's going to go 0 up to your k value, we have to do a subtraction. So the subtraction we're going to do is we're going to take everything up to 9 and subtract off everything below 6. Well, everything below 6 is less than or equal to 5. Remember, the outcomes here are discrete because you can't make 5.5, 6 1/4 shots. You're only going to make 5 shots or 6 shots, nothing in between. So to do this, I'm going to move my equal sign over here. The first one is binom CDF of NPK, so still our 10.48, and in this case, the k value is going to be 9. So there's my NPK. Please note how I'm labeling the inputs and writing probability statements for all things. Might ask you to do that. We're going to subtract off binom CDF of 10.48. And now I want to subtract off 5. I don't want to subtract off the 6 because the 6 is included. So I'm only going to go up to that k value of 5. Again, NPK. And again, you're going to your calculator here. The first value that you should get from your calculator is 0.9994. That's all but the 10th shot being made. So it's going to be a lot of probability added up. Minus 0.6712 for a net total of 0.3282. Again, this problem would look very different if these were not inclusive. If they were exclusive, and it was just between 6 and 9 exclusive, right off the bat I would come up here and cross off the x equals 6 and the x equals 9. And I would only be looking at the probability of x equaling 7 or 8, which means when I did my binom CDFs, I would have here x less than or equal to 8, and here x less than or equal to 6. That would give me just 7 and 8. To be honest with you, at that point, I might just take the sum of the two PDF values for 7 and 8 rather than doing the subtraction of the CDF values. They're essentially the same number of steps. All right, so that's how we're going to be working with binomial probabilities, how we use binomial PDF and binomial CDF. The next video will kind of tackle what happens with the means and variances that we talked about in Chapter 7 and how they come into play in this chapter. All right, hey guys, I hope everything is going great. I hope you're enjoying your last week before vacation. There'll be a couple more videos down the pipe, and I'll see you in the new year.